Okay, so today let's talk about relational operators. So it is used to compare numbers or to determine the relative orders. So here, okay, we have greater than, less than, greater than, equal to, less than or equal to, and not equal to. So Booleans express, okay, you have either true or false. So example, if 12 is greater than 5, so it is a true statement, so it is true. And 7 is lesser or equal to 5, this is a false statement. So if x equal to 10 and then x is equal to 10, then it is true. And if x is not equal to 8, then it is true because x is 10. And x is 8, so it's false because x is 10. Okay. So relational expression, okay, can be assigned to a variable like x is equal to, a result is equal to x, which is lesser or equal to y. So you can assign x for false and 1 to true. Okay. X 0 for false and 1 for true. Do not be confused with this assignment or this relational expression. Okay, this is for assignment and this is for a relational expression. So logical operators, okay, so used to create relational expression from other relational expression. Operators, meanings and explanations. Okay, we have in, we have or, and we have not. So new relational expression is true if both expressions are true. So both sides must be true, then it will be true. And or is new relational expression true? Is true, either expression is true. So if either one is true, it is considered true. Okay? Not means reverse the value of an expression. Okay? A true expression become the false one and the false one become the true. So we can see that this is examples. So let's say x is 12, y is 5, z is negative 4. So x is greater than y, okay, 12 is greater than 5, and y is greater than z, which is 5 is greater than negative 4. So this is true and this is true, so this is true. Okay, and you can see that x is greater than 5, okay, 12 greater than 5, and negative 4 is greater than 5. This is false, and this is n, so it is false. Okay, because for n both must be correct. X is less or equal to z, this is false. Okay, and or y is equal to z, which is false. Both are false, so it is false because it's neither one is true. Okay, x is less or equal to z, this is false, and y is not equal to z, 5 is not equal to negative 4, so it is true. So this is true statement. Okay, and not. So x is greater or equal to z. Okay, x is 12, 12 is greater than negative 4. So this is a false statement, but being reversed it becomes false. Okay, so the AND operator, so you can open your Python programming. Okay, you can open the program, the IDE, and then you type this example. So this example is to congratulate you when your score is above 95. So let's see this example. You can see that score 1, score 2, and score 3. So you need to input the value of first score, second score, okay, and third score. Sorry, this one's supposed to be third score. Okay, so average is equal to float score 1 plus score 2 plus score 3 and then over 3 means you get the average. So if average is greater than 95 and average is less than 100, then print congratulations. Okay, so if only this being fulfilled, you will proceed congratulations, or else it will just print the score is the average value. Okay, so example, you key in 90, 100 and 100, so the average is 96 point something, so it will print you the congratulations. Okay, and if, okay, so let's go to the OR operators. So you can see that here the income is float, input what is your annual income. Okay, and then years, input what, how many years you've been employed. So either one, okay, so or is either one is true, that is true. So if income is greater or equal to 35,000 or year is greater than 5, then it will print you are qualified. Okay, if it's not fulfilled either one, then it will not print this statement. Okay, so for if only it fulfill the statement, the condition, then it will print. Okay, so what is your annual income? So it's 30,000. Okay, 30,000 is less than 35,000, so it will not fulfill the first condition. But then the how many year been employed here is 6 years, which is fulfill the years. So it will print you are qualified. And not, okay, determine the user loan qualification. So again, the same thing as the user income and how many years employed. Okay, so let's say the income is not greater or equal to 35,000 or the years is not greater than 5, then it will print you must earn at least 35,000 or employed more than 5 years. So here you can see that the user gain 3,000 and also 4. Okay, so you will tell user to earn at least 35,000 or employed more than 5 years. Okay, if not, so if not fulfilled, then it will going to print. And this, okay, this is the conclusion of it. Okay, or logical operators not. So not has the highest precedence followed by and or or. So if you in a statement you face these three, okay, at once, so we need to use the or first and then follow by the and or. And or you have the same one, so you will follow from the left to the right rules. Okay, so if the value of an expression can be determined by evaluating just the sub-expression on the left or of a logical operators, then the sub-expression from the right will not be evaluated. Okay, so that's it for this slide.